Hi everyone, this is the 15th lecture in IE451 Engineering Economy. So today we are going to continue to solve end of chapter 4 problems, just 4 or 5 problems more. And then we are going to move on to the next chapter, chapter 5. Okay, so this is the first problem that we are going to solve. Problem number 3-51, which is about the continuous compounding. Okay. Is that correct? And you know, in our textbook, both chapter 3 and chapter 4, both chapters dealing with this continuous compounding as well as the nominal interest, effective interest rate. So we're going to go back to chapter 3 at this moment. Okay. So select the best alternative among the following 5 alternatives. Assume the investment is for a period of 4 years and the present sum of money, P, is $10,000. The first case, case A, is the 11.98% interest rate compounded continuously. And the case B is 12% interest rate compounded daily. And the third case is 12.01% interest rate compounded monthly. And the next case is 12.02% interest rate compounded quarterly. And the last case is 12.03% interest rate compounded yearly. So we have these 5 alternatives with slightly different interest rate and with different compounding periods, right? So this is the problem number 3-51, and alternative A, there is 11.98% interest rate continuous compounding, right? So if I use the single payment compound amount equation for continuous compounding, which is F equals present sum P times e to the power R times N. Okay, R is the nominal interest rate, and the P value is given as $10,000, right? And R is given as 11.98%, so it's going to be 0.1198 times N. N is also given as 4 years, right? So times 4. How much is this? This is $16,000. Little over $16,147.82. Okay. And what about the alternative B, 12% interest rate compounded daily. So B is 12% interest rate compounded daily. So this means that the bank pays 12% divided by 12, right? Which is 1%. Bank pays 1% monthly. We divide by 12 because there are 12 months in a year, right? So in such case, N would be 12 times 4 years, which is 48 months. Okay? Oh, I'm sorry. I was looking at the case C, but the alternative B is about the 12% compounded daily. So this means that bank pays 12% divided by 365 days. So let me rewrite down here. Bank pays 12% divided by 365 days, right? So bank pays this interest rate daily, okay? And in that case, N would be 365 times 4. Okay? So in this case, the future sum money F would be 10,000 times 1 plus the interest rate, which is 0.12 divided by 365 to the power 365 times 4, right? So how much is this? This is going to be $16,159.47. So compared to the alternative A, the alternative B provides more money, right? What about the alternative C? That is about 12.01% interest rate compounded monthly. So 12.01% compounded monthly. So this means that the bank pays (12.01% over 12 monthly. Okay, the bank pays this interest rate monthly. In that case, the compounded periods would be 12 times 4, right? There are 12 months in a year, and the total period we are considering is 4 years. So you need to multiply these two numbers. This becomes 48 months. Okay? So in this case, the future sum of money, F, equals 10,000 times 1 plus 12.01% divided by 12 to the power 48, right? Which is same as 1 plus 0.1201 divided by 12 to the power 48. Okay, so how much is this? Okay, this is going to be $16,128.65. Okay, then what about alternative D? That is about 12.02% compounded quarterly. So again, in this case, bank pays how much? 12.02% divided by 4. Bank pays this interest rate quarterly. Okay? So in that case, what would be the value of n? 4 times 4. There are 4 quarters in a year, and the total number of years we're considering is 4 years. So 4 times 4 becomes 16 quarters. Okay? So the future sum of money, F, equals 10,000 times 1 plus 0.1202 divided by 4 to the power 16. So how much is that? Okay, this is $16,059.53. Okay, for alternative D. And this is the last alternative, E. That is about 12.03% interest rate compounded yearly. So in this case, we can use n equals 4 years, right? And the future sum of money can be obtained by 10,000 times 1 plus 0.1203 to the power 4, right? So how much is this? That is $15,752.06. So how do you answer this question? 3-51. We need to choose the best alternative among these 5 alternatives. So by simply comparing the future sum of monies from 5 alternatives, you know that the alternative B provides the highest value, the largest amount of money, future sum of money. So it will guarantee the largest sum of money in the future. So I do say alternative B is the best case. Okay? So you need to go with alternative B. Okay. Next. Let's solve another problem from chapter 3, which is problem number 3-54. Okay. So department store charges 1.75% interest per month, compounded continuously on its customers' charge accounts. What is the nominal interest rate and the effective interest rate? Okay, so this is the problem 3-54. Like I mentioned earlier, in our textbook, both chapters 3 and 4 talks about the nominal interest rate and effective interest rate. Since we didn't practice a lot of problems, since we didn't practice about these concepts of nominal interest rate and effective interest rate with many example or exercise problem, so that's why we go back to chapter 3, end of chapter 3 problems, okay, which is about the nominal interest rate and effective interest rate. Okay, so how would you get the nominal interest rate? You remember this formula? I equals R over M. R is the nominal interest rate. And I is the interest rate per compounding period. And what is M? M is the number of compounding periods. Per year, right? That is the number of compounding periods per year. So here, from the problem description, we know that I is given as 1.75%. And M is 12 months. Okay? So R is I times M, which is 1.75% times 12 months. So how much is this? That is 21%. Okay? That is the nominal interest rate. Then how do you calculate the effective interest rate. The effective interest rate for continuous compounding. Effective interest rate for continuous compounding can be obtained by e to power r minus 1, right? So here r, which is nominal interest rate, is 21%. So this is going to be 0.21 minus 1, right? So how much is this? .2337. So 23.37%. That is the effective interest rate for continuous compounding. Okay. Here's another problem from end of chapter 3. The problem number 3-56. So Bank North advertises we pay 6.5% compounded daily. Bank South advertises we pay 6.5% compounded continuously. If you deposit $10,000 with Bank South for 1 year, how much additional interest will you receive? So here, 6.5% compounded daily means that the bank pays (6.5%) divided by 365 days. So how much is this? .0178% daily. Okay, that is for the Bank North. Okay, and in that case, M becomes 365 days. Okay. So you want to deposit $10,000 for 1 year. If that is the case, the future sum of money after 1 year becomes 10,000 times 1 plus 0.0178. Oh, I'm sorry, that is the percentage. So 0.0001. No, 0.0178 to the power 365, right? So So how much is this? It's going to be $10,671.53. And what about the Bank South? Bank South. The Bank South advertises they pay 6.5% compounded continuously. So if you deposit $10,000 with Bank South for 1 year, the future sum of money, F, becomes 10,000 times E2 R. What is R? That's going to be 6.5%, 0.065, right? And N would be 1 year. You know, I've used the formula F equals P times E2 power R times N, right? For the continuous compounding. So how much is this? This is going to be $10,671.59. So if you compare these two numbers, then how do you conclude? So if you use Bank South instead of Bank North, you will receive how much more? 6 cents more. Okay? So that is the answer. If you use the Bank South instead of Bank North, you will receive 6 cents more. Okay. Let's solve one more problem from the end of chapter 3, which is problem 3-57. Bart wishes to tour the country with his friends. To do this, he is saving money for a bus. So the first question is, how much money must Bart deposit in a savings account, paying 8% nominal interest rate compounded continuously in order to have $8,000 in 4.5 years? And the second question is, a friend offers to repay Bart $8,000 in 4.5 years if Bart gives him $5,000 right now. Assuming continuous compounding, what is the nominal interest rate of this offer? Okay. So the savings, okay, so for the first case, case A, the savings account pays 8% nominal annual interest compounded continuously. Okay. So if I use the single payment present worth formula, which is P equals F times E to the power negative r times n. Then it's going to be 8,000 times e to the power negative 0.08, which is 8%, times n equals 4.5 years, right? So multiply by 4.5. How much is this? Okay, this is the $5,581.41. What about next question? How to handle this question B? So this question B can be answered very easily by using the single payment compound amount formula for continuous compounding. So what is that? F equals P times E2 power R times N. Okay? Here, the future sum of money is given as $8,000, right? And one of his friends will give him $5,000 right now. So this becomes the present sum of money, P, times E2 power R. And this time, we don't know the value of R, the nominal interest rate of this offer. And what is N? Again, we're going to use 4.5 years, right? So if you, okay, so in that case, E2 power R times 4.5 equals 8,000 divided by 5,000, that is 1.6, right? So if you take natural log on both sides, this becomes log of 1.6 equals 4.5 times R times log of E, and of course log of E becomes 1, right? So R equals log of 1.6 divided by 4.5. So what is this? Okay, this value is equal to 0.1044. So 10.44%. Okay. So this is the answer for part B. Okay. And now let's come back to end up chapter 4 problems. So let's solve problem 4-118, which is about continuous compounding again. Okay. Barry, a recent engineering graduate, never took engineering economics class. When he graduated, he was hired by a prominent architectural firm. The earnings from this job allowed him to deposit $750 each quarter into a savings account. There were 2 banks offering a savings account in his town. And the first bank was offering 4.5% interest, compounded continuously. And the second bank offered 4.6%, compounded monthly. Barry decided to deposit in the first bank because it offered continuous compounding. Based on the foregoing information, did he make the right decision? Okay. So basically, you cannot simply compare these 2 interest rates, 4.5% and 4.6%. Why is that? Because their compounding periods are different each other, right? Then how could he compare these 2 interest rates to make a decision? You have to obtain effective interest rate for each of these 2 cases, right? And then compare them. You remember earlier this class, I have mentioned that each combination of a nominal interest rate and the number of compounding periods corresponding to an effective interest rate, right? So for the first bank, they are offering continuous compounding, right? For 4.5% interest, continuous compounding. So how do you get the effective interest rate for that? It's going to be e to the power r minus 1. Here, r is given as 4.5%. So it's going to be 0.045 and minus 1. So how much is this? This is the 4.603%. Okay. What about the second bank? They are offering 4.5% interest rate, the compounded monthly, right? So monthly compounding. In that case, effective interest rate would be 1 plus r over m to the power m minus 1, right? We have run this formula earlier. It says 1 plus 0.0. Is that same? No, sorry. The second bank provides 4.6% compounded monthly. So we are going to use 0.046 and divide by m. M would be 12 because there are 12 months in a year. And to the power m, which is 12 again, minus 1. So how much is this? Okay, this is the 4.698%. So you need to compare this value from the one in First Bank. So First Bank provides 4.603% and Second Bank provides 4.698%. So what is your conclusion? Did Barry make the right decision? No. Barry should have selected the Second Bank because their interest rate is higher, okay, than the one in the First Bank. So Barry made a wrong decision, right? Okay, so this is the last problem for the end of chapter 4. And we are going to move on the next chapter, chapter 5, after solving this problem, okay? Okay. So, what is the present worth of a series of equal quarterly payments of $3,000 that extends over a period of 8 years? If the interest rate is 10% compounded monthly. So, okay. Problem 4-111. Right? So let's compute the interest rate per compounding period, which is I. Okay, you know, I can be computed by R divided by M, right? R is the nominal interest rate and M is the number of compounding periods per year. Okay. Then what is R? R is given as 10%. And M is 12 because there are 12 months in a year, right? So this is going to be 0.83% monthly. Okay. Now let's obtain an effective interest rate per quarterly payment amount. Per quarterly payment period, right? So the effective interest rate per quarterly payment period be, let's say, I sub quarter. That's going to be 1 plus I to the power m minus 1, right? So that's going to be 1 plus I is 0.83%. So 0.0083 to the power m minus 1. So what is the value of m? That is not 12 anymore. Because we are considering a series of equal quarterly payments, right? And there are 3 months in 1 quarter. So at this time, we are going to use the value of 3 for m, okay? Because there are 3 months in a quarter. So this is going to be 1 plus 0.0083 to the power 3 minus 1. So how much is that? So that's going to be 1.0252 and minus 1. So 0.0252. So it's going to be 2.52%. Okay? That is the effective interest rate per quarterly payment periods. Okay? So these are the tricky part. Here we use m equals 3 because we are considering a series of equal quarterly payments. Okay? And because there are 3 months in 1 quarter, so that's why we are using m equals 3. Okay? Now let's draw a cash flow diagram. Okay? So we are going to compute present worth. Present worth of how many quarters? How many quarters do we have in 8 years? 32 quarters, right? So we are going to compute present worth of 32 quarterly payments. So that's going to be something like this. You want to know the present worth of 32 quarterly payments. Here we have uniform series of $3,000, right? 32, 31, 1, 2, 0. So, right? And the interest rate is 2.52%, right? We just computed 2.52%. 2.52% quarterly. Because this units quarters, right? So how'd you get this p-value? P present sum would be A times P given A, the same interest rate over the n periods, right? Here, A is 3,000, I is 2.52%, N is 32, right? 32 quarters. Alternatively, you can use the formula, because I know the end of chapter, in our textbook, the compound interest table does not provide the factor value for 2.52% interest rate. So let's go with the formula. 1 plus 0.0252 to the power 32 minus 1, and 0.0252 times 1 plus 0.0252 to the power 32, right? Okay, so how much is this? That's going to be $65,363. Okay, so that is the answer for problem 4-111. Okay, so now let's talk about chapter 5. Which is about present worth analysis. Okay. So in chapter 5, we are going to apply present worth techniques in various situations in selecting the best alternatives. Okay? So we have learned that the concept of equivalence can be applied to cash flows that occur at different times. However, which equivalent measure should be calculated and how should it be evaluated? That is the question. We may answer this question by present worth analysis, which means we're going to calculate a time 0 equivalent value, or the abbreviation of the present worth, the PW. So we will also learn about equivalent annual cash flow analysis and the internal rate of return analysis later. And of course, when correctly applied, all of these evaluations, all of these evaluation methods leads to the same results. Okay? However, some economic analysis problems may be more easily solved by one of these methods. Okay? And in chapter 5, we will focus on problems that are easily solved by present worth analysis. Okay? And the present worth, the PW, is the value at time 0 that is equivalent to the cash flow series of a proposed project or an alternative. Okay? So the PW, the present worth measure, the PW, the present worth measure is very easy to understand and easy to use. In the cash flow, as you know, the revenues cash flow, there are revenues that are greater than 0, right? Whereas the cash flows, there are costs less than 0, right? So the standard for desirable PW, the standard for the desirable present worth is PW is greater than 0. Of course, the case that the present worth is negative should be avoided if possible. And when you apply the present worth analysis, we may have these 3 different analysis period situations. For the first case would be for each alternative, useful lives are equal to the analysis period. Of course, this case is very easy to handle. The analysis period can simply be the useful life of devices considered, right? How about the second case, where the useful lives of each alternative are different from the analysis period? If at least one alternative has a useful life different from the analysis period, then one method is to select an analysis period that is the least common multiple of the alternative lives. And another method is to select an analysis period. And in this case, we need to estimate the terminal values of all alternatives at the end of the analysis period. Okay? What about the third case, where there is an infinite analysis period? If you think of roads, dams, and pipelines, their lives are very close to perpetual in an economic sense. So a present worth of cost analysis of these facilities would have an infinite analysis period. Okay? So in this case, we should use special cost analysis, which is called as capitalized cost analysis. Okay? And the corresponding, the present worth is defined to be the capitalized cost. Okay? And the capitalized cost is the PW, present worth of annual cost that are assumed to occur in perpetuity. And it can be calculated by equation number 5-2 in our textbook, which says capitalized cost P equals A over I. Okay? And the derivation of this equation is well described in our text. I believe in page number in our text page number 162. So please take some time to read through the page numbers 162 of our text. Okay? Okay, so I'm going to stop here for today. And next time, we are going to solve end of chapter 5 problems, okay, based on this basic concept. Okay? Okay, thank you. I will see you next time. Bye-bye.